No NASA spacecraft has gone farther than Voyager 1. Launched on September 5, 1977, to fly by Jupiter and Saturn, is the first spacecraft to reach interstellar space. Voyager 1 crossed into interstellar space in August 2012. Voyager 1 performed a flyby of Jupiter on 1979 and a Saturn flyby on 1980. The planetary encounters concluded in 1989. Then the Voyager missions morphed into the Interstellar mission, which prompted exploration of the outer limits of our solar system and beyond. Voyager 1 has long since zipped past the edge of the solar system, through the heliopause, the solar system border with interstellar space, into the interstellar medium. This stunning image was taken while Voyager 1 was en route to Jupiter on March 5, 1979. This image provides a look back at the Earth and Moon. As the spacecraft traveled, Voyager 1 took a shorter route than Voyager 2 and arrived at Jupiter first. Voyager 2 took the more scenic route, visiting Jupiter in 1979 and Saturn in 1981. Successful flybys of Uranus allowed for roughly 8,000 images of the planet and its satellites. A few years later, Voyager 2 arrived at Neptune and collected around 10,000 images. Voyager 2 detected many significant changes, including a drift in the Great Red Spot as well as changes in its shape and color. Voyager 1 has moved and passed the edge of the solar system, through the solar system border with interstellar space, known as the heliopause, and into the interstellar medium, have detected the sounds of plasma waves. Voyager 1 is sending back a far more subtle signal, the constant of the interstellar plasma. This low-level vibration is fainter, but much longer lasting, than the oscillations that occur after coronal mass ejections. May 10, in the journal Nature Astronomy, the hum lasts at least 3 years. That is good news for researchers to gaining a better understanding of the interstellar plasma. Stella Cocker, it's very faint and monotone, because it is in a narrow frequency bandwidth. We are detecting the faint, persistent hum of interstellar gas. Scientists believe that the space through which Voyager 1 passes, known as the interstellar medium, is filled with different types of waves, large and small. These waves can provide information about the density of the interstellar medium. Scientists says instruments on Voyager 1 identified the waves as vibrations in small amounts of gas found in the near emptiness of interstellar space. The vibrations are also known as plasma waves. The spacecraft detected the waves over several years at different radio frequencies. Voyager 1 became the first in situ probe of the very local interstellar medium. The Voyager 1 plasma wave system gave point estimates of the density of the plasma covering about 30 of interstellar space, revealing a large-scale density gradient and compressive disturbance outside the heliosphere. James Cord said, "The interstellar medium is like a quiet or gentle rain. In the case of a solar outburst, it's like detecting a lightning burst in a thunderstorm, and then it's back to a gentle rain." This discovery of the emission suggests that Voyager 1 will continue to be able to detect it, providing scientists with ongoing readings that will help them understand turbulence and the large-scale structure of the interstellar medium. Shami Chatterjee said, "We have never had a chance to evaluate it. Now we know we don't need a fortuitous event related to the Sun to measure interstellar plasma." Voyager 2 is the first and only spacecraft that has flown close by one of the more enigmatic planets in our solar system. 25 years ago today, Voyager 2 made the close pass, and scientists have been reminiscing about how they pored over the data being returned by the Grand Touring Voyager 1 and Voyager 2. Voyager 2 made many remarkable discoveries came from this cosmic meetup. Uranian day is just 17 hours and 14 minutes long. Uranus' atmosphere is similar to that of the other gas giants, composed mainly of hydrogen and helium. Below that lay water, ammonia, and methane ices. Voyagers provided NASA here on Earth with important observations combined with those of Voyager 1. Spilker says, "The first flyby was unique in that we found so many interesting new things. We got to see the detailed structure, for instance, in Saturn rings." With these data in hand, the scientists on the ground could plan for the next flyby and what they wanted to find. We could go in and tweak the designs and the observations for Voyager 2. also said, Voyager 2 took a closer look at Saturn rings, particularly the narrow, outermost F ring. We saw a lot of changes in that ring, in particular, these sorts of kinks and braids that we could see in that ring. In 1981, the Voyager 2 spacecraft made its closest approach to Saturn. Although its sister Voyager 1 crashed 9 months ago and the Pioneer 11 spacecraft overtook it 2 years earlier, Voyager 2 has concluded its first close examination of this intriguing planet. Launched 6 days apart, the NASA probe was important for analyzing how Saturn's atmosphere changed with the seasons, as they measured the wind speed and temperature and density of Saturn's atmosphere. At Jupiter, the Voyager 1 and Voyager 2 gave our first detailed ideas of how the planet's atmosphere evolves. Great Red Spot was a counterclockwise rotating storm that interacted with other Voyagers. Voyager 1 and Voyager 2 observed some of Jupiter's moons, discovering Eo's volcanism, granting Ganymede the title of largest moon in the solar system, a superlative that was previously thought to belong to Saturn's moon Titan. According to Smithsonian Mag, Voyager 1 started seeing signs that the end was near, prompting some observers to talk about the solar system's edge. The solar wind should slow abruptly as it presses against the space beyond, and Voyager saw just such a change. A twin probe, Voyager 2, saw the same thing in 2007. Last year, Voyager 1 witnessed another exit sign. Todd Barber said, the Voyager team got more excited each time, with each milestone in the thruster test. In a statement, the mood was one of relief, joy and incredulity after witnessing these well-rested thrusters pick up the baton as if no time had passed at all. In addition to its successes in exploring exoplanets, Voyager 1 travels to interstellar space before any other spacecraft. It testifies to some aspects of humanity and our place in the universe in the form of the Voyager Golden Record. Voyagers are the carriers of messages from humanity to possible civilizations in interstellar space. The Golden Record consists of 115 analog-encoded photographs, greetings in 55 languages, a 12-minute montage of sounds on Earth, and 90 minutes of music. Ferris says there are 1,000 worthy pieces of music in the world, for every one that is on the record. I imagine the same could be said for the photographs and snippets of sounds. The Voyager 1 and Voyager 2 scientific mission will end when their plutonium-238 thermoelectric power generators fail, around the year 2030. After that, the two craft will drift endlessly among the stars of our galaxy. Thanks for watching. See you in the next video.